This video provides some information on drawing and fitting a straight line graph in Origin. Once you open the new Origin file, we can enter in some data. In column A, we can enter our x-axis data, for example time. The long name is time and the units are seconds, s. Column B is the y-axis, or the response observed at different times. Let's say we are measuring temperature as a substance is heated. I record the long name as temperature and units K for Kelvin. For this example, I will enter in some model data. We now want to represent this data on a graph. With the mouse over the column heading, I can select both columns. To start my graph, I select the plot menu and the scatter option. Scatter will draw data points without joining them. We can see the output here. The column long name and units have transferred to the axis label and units. Now to draw the best fit line, I select a data point and choose Analysis menu, Linear Fit, and opt for the Open Dialog menu option. We won't spend too much time here as the default is OK. The only thing to turn off is the Fitted Curves plot. Here we will turn off the option to update legend on the source graph. It avoids unnecessary clutter on our output. We can move the output information so that it doesn't cover the plot. We'll have a look at this in more detail in a moment, but for now it's enough to say that we can see the slope and y-axis intercept of our plot in this output. Let's add in some more data. To make another column, click on column B and press Ctrl D to duplicate the column. We'll add in one more this time, so I select 1. Again, we'll enter in temperature data, but this time it's not going to be as perfect. You'll see I'm entering numbers that are just above and below those data in column B. I'm also adding in a comment to say that this is experiment 2. Again, we want to plot this data. This time column A is the x-axis and column C is the y-axis. To select different columns, I hold down the Control key as I select. You'll see in this output the data isn't as neat. Let's fit the curve as before. We can choose last used at this time as we're not changing anything, and we don't need to open the dialog box. Again, we get a data output, and we can move that so that it doesn't obstruct the plot. We can see the fit isn't as good with some points on either side of the line. The slope and intercept are available as before. However, now we can look more closely at other values. We are given the Pearson OR value and the OR squared value. These give some sense of how good the fit is. We also have standard errors for our slope and intercept. Okay, last time, in real situations, you'll more likely want these plots represented on one graph. Before we do this, let's label column B as experiment 1 so that we can distinguish each set of data on the graph. To highlight all data, we click on the first, hold the Shift key and click on the last column. Then we can select Plot Scatter as before. The graph produced shows both plots, and we can see the comment section, experiment 1, experiment 2, are used to distinguish between them. We can generate the best fit lines as before by clicking on a data point and selecting Analysis, Fitting, Linear Fit. After moving the output box, let's look at this more closely. We see the output now has information for both plots. We can see the Pearson's OR and OR squared value are 1 for the first plot, and the slope and intercept are displayed for the first plot in the first 2 rows. Have a look at this carefully because it's a bit confusing at first. We can navigate to the individual plots in the left-hand screen if you want to check yourself. Here's plot 1 and its data, and here's plot 2 and its data. Check again on the combined plot to see where it appears there.